Good morning, afternoon, or evening. Welcome back to Mr. Morrell's Algebra 1 and 2 class. And today we're going to continue with polynomials. And we learned how to add and subtract polynomials yesterday. We learned how to recognize the degree of a polynomial. And we know how to name it by both degree and number of terms. We also know how to write polynomials in standard form. We also know what disqualifies a polynomial. You can't have variables in the denominator, can't have variables with negative exponents or with fractional exponents, can't have variables inside of radicals. Okay, so today we're going to take all that knowledge and learn how to multiply just monomials today. When we get back next class, we're going to learn how to multiply polynomials. And then in that case, we're going to multiply monomials to binomials, binomials to binomials, trinomials to binomials, any kind of polynomials. And it's really simple. But it's going to be really simple if we learn today really well. So the first thing I'm going to start with, my friends, before we can multiply any polynomials, we have to learn what's called the product rule for exponents. Please pay attention to this, okay? These are rules that are going to allow us to manipulate the exponents. The product rule. If A is a real number and M and N are natural numbers. Remember what natural numbers mean. Positive numbers greater than 1, positive whole units. So natural numbers are things like 1, 2, 3, 4, 5, 6, 7. Okay? Remember, those numbers cannot be fractionals. So, and actually they can. Actually they can. You know what? I don't like that. No, because that's false. No. Change that. They can be real numbers, because you can have negative exponents. Yeah, they're just not polynomials, but you can still do it. So, if A is a real number and M and N are real numbers, then A to the M times A to the N is A to the M plus N. What does that mean in English? It means the following, guys. If you multiply the same base, keep the base, and add the exponents. That's it. Literally. Okay? Now, what is he talking about base? Remember, whenever we have a value and an exponent, the actual main value, that's called our base. And of course the n is the exponent. I know we had a lesson on this earlier in the year, but just in case. The base is the number being raised to the power. So when I have this same base and I'm multiplying the same base, okay guys, you're going to keep the base and you're going to add the exponents. For example, let's just tear through some. 2 cubed times 2 squared. 2 and 2, the same base. So I'm going to keep the base and add the exponents. And 2 to the 5th, 2, 4, 8, 16, 32. Done. X to the 4th times y to the 8th. Wait a second. Are those the same bases? No, so I cannot do anything with those exponents. It stays the same. How about m cubed times m to the 5th times m? Are all of those the same base? Yes, m. m to the 3 times m to the 5 times m to the 1st, because there's an invisible 1 here. That's going to be m to the 9th. You have a question, sir? The question was in the quiz, will I have to actually calculate this? Yes. Yes, of course. If it's not a reason, you know, as long as it's not an unreasonable number. If I give you 72 to the 9th power, I'm not going to make you do that. Thank you, sir. Negative 3 squared times negative 3 squared. What's the base here? Negative 3 on both. They're both the same base. So please be careful when something like this. Notice how they're in parentheses. That's the base. So it's negative 3 to the 5th power. So again, negative 3 times negative 3 is 9. Times a negative 3 is 27. Times a negative 3 is positive 81 times a negative 3 is negative 243. One little hint. When you have an odd exponent with a negative, the answer is going to be negative. When you have an even exponent attached to a negative, the answer is going to be positive. X to the 8th times x to the 8th. That's x to the 12th. Thank you. Same base, add the exponents. A to the 4th, b to the 5th, c to the 3rd times a squared, b to the 4th, c. There you go. A to the 6th, b to the 9th, c to the 4th. I couldn't have done it better myself. Excellent. Excellent job. Well done. Does that make sense? All right. Cool beans. Next, the power rule. The power rule. If A is a real number, and again, I'm going to change this. I don't like this. If A is a real number and M and N are real numbers, I don't know why I put natural when I was writing the notes. I'm sorry. Then this is what's going to happen. If I have A to the M raised to the nth power, that is going to equal A to the M times N. If I have A times B raised to the nth power, I am going to have A to the N times B to the N. What does this mean? It means the following. When you raise a power to a power, comma, keep the base and multiply the exponents. Okay? When you raise a power to a power, keep the base and multiply the exponents. You are literally, guys, going to take this outside exponent, you're going to distribute it to everything inside. In this case, it's just the m, bless you. So that's a to the mn. But in this case, please pay attention. Everything that's inside of here has an exponent. You may not see it because it's an invisible one, but it's got it. So this outside exponent gets distributed to every exponent inside. A to the 1, 1 times n is a to the n. B to the 1, 1 times n is b to the n. So whenever you raise a power to a power, you're going to distribute that exponent to every single exponent inside of the parentheses. So if I have this, check it out. This is going to be x to the 8th, x to the y to the 12th, over z to the 16th. When I raise a power to a power, I multiply those exponents. I distribute the outside exponent to everything inside of the parentheses. Does that make sense, guys? Okay, give me 1 second, please. Okay, sorry about that. So, let's practice a little bit. 2 cubed raised to the 2nd power. Well, that's going to be 2 to the 6th. 2, 4, 8, 16, 32, 64. Y to the 4th raised to the 5th. Distribute it. That's y to the 20th. xy squared raised to the 3rd power. I'm going to distribute that exponent to every exponent inside, my brothers. So that's x cubed, y to the 6th. Now this one, don't be stressed. This is negative 3 cubed raised to the 2nd power. So I take the outside exponent, I multiply it to every exponent. So that's going to be negative 3 to the 6th, right? Which then, let's see, it's going to be 9, 9, and 9, 729. Very good. It's going to be positive. Excellent job there. Excellent job. Negative, okay, now here, be careful with this one, guys. Negative 5n to the 5th, okay? I'm going to distribute this negative 3 to the 5 and to the n. So this is going to be, in parentheses, negative 5 cubed n to the 15th. Now, here's where we separate the A's from the B's. This negative 5 cubed, is the 5 being affected or the whole negative 5 being affected? The negative 5. Because isn't it inside of parentheses, guys? So if you wanted to help yourself out, you could put that in parentheses. Negative 5 cubed is going to be 125 n to the 15th. Be careful with those negatives. That can really get you. Yes, sir. Yes, it would be negative 125. I was testing you, and you passed. Okay. Here, I've got negative 6 in parentheses cubed, x to the 9th, y to the 6th. So that's going to be 180 and negative 216, x to the 9th, y to the 6th. Does that make sense, guys? You promise? Yes, sir. On D? Yes.
I distributed the exponent, but not the 2 first. I did the 3 first.
No, there is no, well, oh, no. Don't do that. What my boy did was he first did negative 3 cubed, and then he squared it. Be careful with that. Stick to the procedure. Multiply this guy times this guy first. Correct, sir. Thank you, my brother. Excellent. All right, and now we're going to just put it all together, guys. It's no big deal. Let's just put it all together. I've got 5x squared times 6x to the 4th. So am I multiplying or am I raising to a power? I'm multiplying. So what's 5 times 6? 30. X to the 6th. Done. Okay, here. What's 2 times negative 5? Negative 10. P to the 5th. When you multiply the same base, you add the exponents. Now, here's the good one. You see how I'm raising these to a power, right? First, distribute the power, then multiply. So this is going to be, in parentheses, negative 3 squared, x to the 4th, y to the 6th. So that's 9, x to the 4th, y to the 6th, times 2 to the 4th, x to the 12th, y to the 4th. So I've got 2, 4, 8, 16, x to the 12th, y to the 4th. Now I can multiply. 9 times 16, that's 90 and 54, 144. X to the 16th, y to the 10th. Does that make sense, my brothers? Any questions on that? Yes, sir, 144. 9 times 16 is 144. Yes, sir.
Would they like solve the equation and then otherwise?
Okay, wait. Let's see what we just said there. The question was, will they make you solve the equation? There is no equation.
They solve that and then they say.
Okay, wait. Hold on. Wait. Our vocabulary, we need to work on this. You're telling me, can we solve this? No. How can you solve this? First of all, I don't have an equation, so you can't solve. Secondly, I haven't given you a value of x or y. Now, if you're asking me, can I evaluate this, Mr. Morrow? Yes, but you have to be given, let's say x equals 2 and y equals 4. If they give you that, then you plug it in. It's called evaluating. But I just don't want your vocabulary to be messed up. Equations have an equal sign. That's when you solve. Okay, my brothers? No, thank you. Have a great day. Thank you very much. Hope you learned a lot.